No, time's up. So welcome everyone to this second day NordicWay 3 final webinars. My name is Olli Rossi. I work on the FinTraffic, and which is a Finnish government-owned traffic management company. And today we can hear some really nice presentations about Finnish C-ITS studies and deployments. And I apologize my voice since I got a flu last week and my voice is not fully recovered after that. So couple basic things first. So I'm your moderator today. However, I have also my own presentation, so I have a co-host here. Ilkka, Juhan and Nico will assist me today. And like you notice, you are muted today. And if you want to ask something about the presentations, please write your questions to the comment box. So we will handle those questions after the presentations. So each presentation will take approximately 15 to 17 minutes. And after that, there is a 3 to 4 minute question and answers sessions after each presentations. So we have today really nice setting of the C-ITS presentations. First, Ilkka will tell you something about the roles about the C-ITS, since this is the new thing in the industry. So, and in the authorities, we need to decide which responsibilities belongs to which one. Then after that, I will tell you something about our pilots in Tampere regarding the traffic light C-ITS data. After that, Nico will tell you something about the interoperability and C-V2X technology. Then Ville will tell you something how to utilize the commercial mobile networks in the implementation of the C-ITS services. And last but not least, Johan will tell you about the cybersecurity and cellular networks. And the closing words, Pekka will tell you a couple words regarding this session. I think we are ready to start. Ilkka, are you ready to share your screen?
Yes, I'm ready in here. Just.
Thank you. The stage is yours.
All right. Thank you, Olli, for the introduction, and you can see my screen there as well, I assume now. Perfect. So great to meet and see there's a lot of people today. My name is Ilkka Kotilainen. I come from the Trafficon Ltd, which is a Finnish consulting company, and this work has been done together with VTT, Technical Research Center of Finland, and we have today in the webinar also other members who have been working with this study, Jos Colliers and Risto Kulmala at least, maybe Ernie Risto as well. So after the session you can please ask questions, and there are several I have to answer. I will introduce you the other partners and the authority partners in a moment. The topic is authorities' roles in implementation, operational use of C-ITS services in Finland. It reached preliminary results because we want to be very precise with the authorities on what to publish. Although it's almost finalized, there's few cybersecurity things we want to check up before we make it a public report, but that will be coming publicly available very soon. Also, we want to make a short introduction today when there's several presentations from Finland to share you what's the composition of the administrative sector in Finland, so you little bit get familiar with the names. First of all, here on the left you can see the Ministry of Transport and Communication, of course leading this administrative sector of the transport, and on the agencies after 2019 we have Finnish Transport Infrastructure Agency. Jari Müllerinen in this work has been working from there, and then the Transport and Communications Agency Traficom, which is the second together with Infrastructure Agency, the funder of this project, and Anna Sirokov also today present this in this webinar. And Olli, just what you see on the screen and starting the webinar, he's from Fintraffic, and they have been also part of the steering committee and many of the projects you will be hearing today. Meteorological Institute also have been part of the project. Broadcasting companies in are not, but other mentioned have been. So there's a little introduction on the transport administrative sector. Then content of this presentation. First, I give you a short background, objectives and methods, and the summary concludes on our proposal, what would be the roles for the C-ITS implementation in Finland, how would we organize them, and also we had a third topic on the automated vehicles, what would be the implication for roles when the automation advances, and finally then a few discussions and recommendations from the study. There's a note here below that the requirements of roles in the European Union C-ITS security credential management system is a separate presentation. This is why we wanted to pack the cybersecurity topics in one presentation, and Johan's Colliers will later give you introduction to those. So then you will also hear about the roles of the authorities in cybersecurity in C-ITS. So first on the background, I already mentioned you were the project partners funding from the Traficom and Transport Infrastructure Agency, the Ministry, Fintraffic also, but then we also included the city of Tampere in the management group of the project, and Traficom we did the consultancy implementing project as mentioned. The aim was to have a question how the C-ITS services be implemented in Finland, what are the different actors and their roles in the implementation and in the infrastructure required by C-ITS, and when the C-ITS services are monitored. And the final third question was that when the automated vehicles, the deployment advances, would there be any new responsibilities or road when the C-ITS messages are distributed. So you can see on the right part of the C-Roads project, of course. Methods, literature review was our main method. So of course we had a cooperation management group, and we have several interviews on the management group organizations here in Finland. We had 2 workshops, one in NordicWay collaboration, so between the NordicWay 3 partners, and then we had one Finnish workshop on the legislation, and of course expert knowledge on the other members. So in short, the methods, and I give you a short summary of the legislation that we reviewed in the literature review during this project. We actually had a quite extensive legislation, over 100 legislative papers were reviewed, and here's just a very short summary of those. So of course the ITS Intelligent Transport System legislation, which included the draft delegated act, which is not in effect from 2019, and the Finnish national laws. Radio equipment legislation from European Union and national both, and then legislation for market surveillance and information security and protection. It's also quite an extensive review on that. There's a lot of accreditation of market surveillance, data protection, type approvals for the motor vehicles, road safety, traffic systems, and different security assessment applications. This also then includes cybersecurity legislation for the networks directives, network information system directives through the union, and other national legislations or Finnish legislation, road and street network information systems. There's the land use and other regulation of agencies and ministries. And of course, there was a short section on the under preparation European legislation. Then the summary of the results. First of all, to aim that this is a proposal, how the authorities' roles could be organized in Finland, made during the study. And the main base for the proposal is from the C-ITS Delegated Act, as mentioned, not in effect from 2019, and second one from the European national legislation, and third using the zeros platform specification and reports where the European harmonization is done. Next I'm going to present you the proposed architecture description, and it's based on the ISO standard, which it's divided in 4 different sections: the policy framework, system management, system operation, and service recipient. And this is also the same ISO standard which is used in the zeros working group 1 on organizational aspects. And here you can see the whole architecture. I will just summarize just on the framework from the ISO standard. What I mentioned are the different colored boxes here. So policy framework on blue, then the red system management and system operation on green, and then the service recipient, so the user here on the right, then in gray color. Basically the policy framework here, in the next slides are the summary of the proposed roles, but here are the authorities roles. The infrastructure agency has a road authority here on the system management, and system operation then includes the economic operators as well, and for the C-ITS station and station operators. And these include now the central or fixed stations, national access point, central station operation, and possible other C-ITS stations here. So this is a very general, but here is the more shorter summary. So what we propose in this report is that for the policy framework, the competent national authority and all the market surveillance as well as the radio equipment role in Finland would be for Finnish Transport and Communications Agency, Traficom. There are quite several roles, as you will see short. And the system management then, so who will manage the whole C-ITS, that role would be for the Finnish Transport Infrastructure Agency and the municipalities. So the municipalities would have their own choice to implement as well. And the system operation itself would be for the FinTraffic, for the traffic management company in Finland owned by the government, and also for the municipalities. And also there's a note now, although we look mainly on the authorities roles, the economic actors can also lead, manage and operate C-ITS services. So of course it's an open market. So if there is an economic actor setting up central station or similar, that could also be possible. Here is the summary of the different actors and their roles. And as you can see here, this is now the policy framework. So all of these roles are for the Finnish Transport and Communications Agency, Traficom. So this includes now all the supervisor, market surveillance, etc. And also the 2 new roles in here, which are currently not existing because of lack of legislation and agreement of these, is the competent national authority of C-ITS. So this is named in the draft delegated act, for example, and then the market surveillance authority for C-ITS stations. And this we concluded that goes well together with the radio equipment and use of radio frequencies, which is already in legislation for the Transport and Communications Agency. Then the second and final slide is a summary of the roles for a new role proposal. So the implementation itself, this would, as mentioned, for the Transport Infrastructure Agency or for the municipalities. And the second new role there was for the traffic management company in Finland, which also we concluded or suggested would have the central station operator role. So this could be for the primary of the company for traffic management or for the subsidiary company of the FinTraffic, the FinTraffic Road. So both could be possible. National access point and station operation. As mentioned earlier, the C-ITS credential management system roles will be a separate presentation. I will show you the few architecture slides on the proposal how to organize then these roles when you implement this C-ITS services, and we made a suggestion for 2 services, mainly because road warnings and traffic light services, as we know in NordicWay 3, they are quite far away already implementation and already tested. So we have a proposal how these roles would go in the implementation itself. We don't go too detailed because of the schedule here, but just to point out here now the main points. So service definition here on the left side, you can see it would be from the Transport Infrastructure Agency's role. And then the owners and operators would go here to the service provision using the long-range cellular communication. And here then the FinTraffic could be the owner and operator when the service is then sent forward to service provider and forward to C-ITS service providers and end users itself. And the same also then for the traffic light services in Finland. The service definition, as mentioned, could be the FinTraffic in this case, or the municipalities. The municipalities have, of course, traffic lights, and these could be then defined together with the traffic light owner, traffic light operators, and traffic light manufacturers in collaboration. And the provision itself, again, from FinTraffic or from municipalities. So from the message publisher to the authentication and to the service providers and end users. So the up part again is the long range communication and the short range communication for the economic actor, for the manufacturers. Then we go to the final steps, also discussions, just to mention the road traffic automation actors and roles, possible effect, not clear roles yet, but assume that it would be the same kind of as for the human users, when user is a human or automated driving system. So the roles would be similar. That we know for sure then that the joint operator for automatic fleet operators, they would be definitely the users of the C-ITS services and distributing the CS messages, for example, OEM or robotaxi company. And also the remote control centers could be one of the end user roles operators. Final slide on discussion and recommendations. The existing legislation, in this case, we recommend it should be applied to C-ITS services or other similar type of services. So no matter what technology or communication protocol you would implement, you would still use the suggested legislation roles. Municipalities and cities have certain right and place and technical equipment. So if they would want to install short-range communication radio beacons, for example, alongside the roads or buildings, they could have a right for that. So from the legislation. And then also we recommended national working groups or similar bodies to coordinate the national implementation. This would be, of course, done in the European collaboration as well. Road traffic automation can set certain requirements for timelines and reliability, and of course C-roads work in this case. And the security part is then in the next presentations. I believe our time start to be up, and also leave time then you to write for the other questions. There we can then later answer for those at the end of the presentation now. Thank you on my behalf, and you can see the contacts and the source later if you want to go see the report itself. Thank you.
Thank you, Ilkka. We have at least one question. Yeah.
All right. Also, thank you, Anna, for the question. So this role, has there been a discussion, analysis of the requirements of the budget and whatever budget element with the authorities? Yes, for the of course this goes more maybe this question to the authorities. I don't know if some of the Finnish authorities want to answer these questions. In scope of this project, we didn't discuss or study the budget alignment. This would be for the authorities.
Then there is another question. Will the slides be distributed after the meeting?
I would guess, yeah.
Yes.
Yeah. Yeah, maybe the NordicWay free website then later.
Yeah.
They will have it. Now I don't see, I also opened the question section. I don't see the other one, but I have one question to Olli.
Okay.
If you don't mind, since we have here in our study recommendation that we would be setting up or recommended setting up national working groups to coordinate the C-ITS service deployment in Finland. And as we happen to know, there has already been few meetings in Finland in 2023 where this C-ITS deployment has been discussed together with the public authorities and private industry related especially for the traffic lights, for example. And I know, Olli, you have been chairing these meetings. Would you want to share a few experiences or what's the situation there?
I think the authorities has waiting for this proposal for the roles, since it is still quite unclear. So I think we need to lock somehow those, what are the responsibilities of the different authorities. After that, I think we could manage to make those strategy groups and that kind of things. But now we have different proposal how to manage that and how to do that. But I think it's still just a proposal. And we make couple workshops regarding about how we should manage to this C-ITS and that kind of things. But yeah. But
thank you, Olli.
Yeah, but this need to think like a ecosystem. It is not a traffic system. We need to take apart also those companies and every stakeholders, which is including this kind of work groups. This is different mindset, this kind of C-ITS. Okay. Are we ready, Ilkka?
Yeah, if there's no other questions.
No, I
as
cannot
I said,
see.
the report will be published later. Thank you.
Yeah. Okay. I will share my screen now. Yes. To the next presentation, which is catering and sharing traffic light C-ITS data. Insights from the C-ITS pilot in city of Tampere. Like we are saying that this is the pilot of the city of Tampere, it consists of the several different pilots and projects. And I will now tell you something about the SPATEM and MAPEM messages, how we transfer from TLCs those messages to the Tampere node, to the TLX platform, and also we have that interchange node platform and trying to take the connection to the other NordicWay 3 interchange nodes. So those circulate places are those what I now show you, and Nico will tell you more about those road charge units and onboard unit pilots. But this is the picture what describe a little bit this Finnish C-ITS pilot ecosystem, what we are done in the NordicWay 3. In the Tampere C-ITS pilot, our scope was that once that we increase our understanding of the technical requirements, what we need, what kind of requirements we need when we are collecting and produce this kind of C-ITS data from traffic lights, controllers and intersections. And is the data interoperable? Is the data predicted? Or the data consistent and high quality? And what are those technical requirements? And our use case was that we will collect the data from multiple devices of different suppliers and different traffic light control principles into one system. So we want that we have different suppliers. Back in 10, there was 3 different suppliers, and also we want to get some different control methods. There is those adaptive system, There's a traffic actuated control method and also that coordinated Finnish Syväri system. And we want to collect those in the one places. So we make first a study, then we take a technical part of that, and last we try to make some validation for that data. And our participants, what we have here in our piloting, we make this together with city of Tampere. So Mika Kulmala was one of the orderer here. So first we make the pre-study with the Mattersoft, then we make this interchange node or the platform where we want to collect and exchange the data together with the Nodeon, who represent the monodes. And that was setting up that was one project. Then we take another project, how we can collect the data from traffic lights to that system. And then we have a Svarko. Back in then there was a Dynic. After that, during the project, Svarko acquired Dynic, so then we have only Svarko and Normivalaistus, who represent the La Semaphoricas traffic light controllers. And data quality was made by Rumble, and also Solita made us to the interchange node based on that Kuwait open source system. And also Traficon was our consultant in different projects and different tasks. Our pre-study, that we interview every stakeholders, what we can imagine regarding the C-ITS, and after that we start the pilot phase. And we have agreed on every stakeholders that the use cases, and we need a consistent calculations of metrics. We define this Tampere node and where the data will collect. They include devices from all suppliers, and we start with ease was our mindset that just collecting the data to the one place. And during the production phase, we noticed that it's important to consider the zero's compatibility. So our traffic light C-ITS use cases was disclosure, and regarding of that, more or less the SPATEM and MAPEM messages. We did not take in the pilot scope those traffic light prioritizations, since why we drop out those, we think we already has in Tampere, every buses and trams has the prioritizations, and there is already onboard units. We have already emergency vehicle priority in each fire trucks and ambulances in Tampere. So we did not see that we just changed the technology. It is not in our scope. Another one. So we consider the SPATEM and MAPEM messages. So short summary, what are those messages? SPATEM messages is the signal phase and timing extended messages. So it will show you the real-time traffic light phase. Is it red, green, or yellow? And also it will give you up predictions, which is the interesting part, and some attributes relating to that prediction. And also, what is the interesting part? How good is the prediction for the next 5 seconds, for the next 10 seconds, for the next 15 seconds, for the next half a minute or the next minute. Everyone who know how the traffic light works, and if you have traffic actuated plans, knows that it's impossible to predict the next minutes how it should work. Or if you want good prediction, you need a quite fixed system. And then there's lots of other waiting times for the cars who is waiting for the reds. Another interesting part was this mapping messages, which is the topology and geometry of the intersections. And how should that be defined? How long should be that lane be? For example, in some cases, if the traffic signal is coming to the, for example, infotainment or some mobile app, how long the lane should be that when it appear to your cockpit or in the infotainment. So there is no definitions about that. And also how you should manage those mapping messages after if you some changes or something like that for handling those. So in Tampere, we take 12 intersections. These are Swarco's, EC2s and ITC2s, and also those Cartesios La Semaphoricas. We have, like I said, control method, adaptive, coordinating, and traffic activated intersections. I need to speed up a little bit. So how we transfer the message from the TLC to Tampere node? First, we look at of course, the C roads, the Mapperman's pattern handbook. Then we take the TLX platform. Okay, there is a SE interface. However, then we notice, okay, how we should produce those in the technical point of view, in the traffic light controllers. So we look to the Dutch ITLC architecture, where is a good specification how to manage those messages in the traffic light controllers. So we use that architecture. Also, our Tunic and Swarco's controller already has those architectures, so only the normal values need to develop that architecture in their traffic light controllers. And after that, we set up the interstate node, which we put the side of the NAP, Finnish NAP, and we try to relay those C-ITS messages, SPATEM and MAPEM messages from Tampere traffic lights node to the other interstate node. And also try to learn how to build this kind of permanent architecture services. And we utilize these open source Buvet systems, and you can use those open source code from GitHub. And our interstate node execution plan was that we set up it to the Amazon Web Services, and that we could make. Also, we could make this connection to the Tampere node. We study those messages. However, still we trying to establish those connection to the Swedish nodes. And I would say it will be ready on the coming weeks, or we take a connection to the federated network. Then we have this data quality control, and the objective of the work was to validate and accurate and the usability of the information produced by the traffic light system. However, we're facing some issues for that. The availability of the source data we need for that work wasn't so good that we think, and we should have more TLCs and intersections to get more data which to validate. So we have two less intersections and two less data to make that data quality control. So at least we now know what are the issues for the and how we should continue this data quality control. And currently the implementation of the validation of the entire system is not possible. So lessons learned last. So we learned that we need to increase the amount of hardware and computing power in the field if you want to use the C-ITS system in the traffic lights. No matter if you are using existing data communications. And configuration, at least in the early stage, is labor intensive and takes time. The devices and compatibility were not as ready as we anticipated. We have some challenges that with the stability of the controller basic operation. So in some cases we have a yellow flashing of the intersections because of some bad happens. But now we all have better understanding what needs to be considered when writing C-ITS requirements. Also, the suppliers understand better the demands of the customers, and also the suppliers understands what we are demanding and what they need to do when they are implementing this kind of C-ITS systems. However, like I say, the overall picture is still unclear. Regulation and roles are incomplete. The ETS directive about the C-ITS is still working. Then other things what we are lessons learned in Tampere. Processes are needed. How we can maintain mapping and spotting data in the changing world. As the number of the users grows, we need a dialogue between stakeholders. We need to ensure the data reliability and availability, and we need monitoring, control, and oversight. And also the funding of the interchange node is unclear still. Should it be like NAP, or should it be that in every city has own C-ITS platform or this kind of interchange node? And like I say, this is an ecosystem. Like I think if you listening last day, I think Menno says good also that this same message is that this is an ecosystem. It should handle like an ecosystem, not like a local traffic system. So what are our next steps? So we validate and comparison of the C-ITS messages. We will try to finalize the connection to the federated network in the coming weeks. We will keep the node available still to the possible system extensions and need to test interoperability with other systems as well. And we are developing a technical requirements specification for the traffic lights regarding the C-ITS services. So we can designing a technical architecture for the traffic lights. So now I'm ending my presentation. Thank you.
Thank you, Olli. There is appeared one question from Bernard Murzo. regarding the question regarding your picture, but basically the question which he asked is directly related to the next presentation of from Nico, who will explain, who will describe the pilot which we have indeed for PC5 LTE. And he asks the reason for the discussion, the decision. Basically, I can perhaps directly answer that. So it was the wish of the Finnish authorities to also test this LTE-based communication method instead of the older ITS G5 technology. Are there any other questions? I don't see. Then perhaps we can go to Nico's presentation regarding the LTE pilot.
Yes. Stage is yours, Nico. Go ahead.
Yes, hello, can you see my screen?
Yes.
Okay, great. So hello everyone. My name is Nico Kynsjärvi. I work for Nordic Finland, and I'm here to present our project we have done together with VTT, the Technical Research Center, and Normivalaistus. And this project was done using cellular vehicle-to-all technology on C-ITS environment. So first, some background of the project. There was basically 4 main goals for the project. First of all was to demonstrate the functionality of the EU C-ITS credential management system, so the EU CCMS, test cellular vehicle-to-all, short-range PC5 and long-range technologies, and to also demonstrate the compatibility of these technologies together with the EU CCMS. Demonstrate the interoperability of C-V2X technologies together with C-ITS services defined in C-Roads platform, and finally to test and demonstrate the use of simultaneous dual communication in a single intersection. So the long-range and short-range communication, which we did in the city of Tampere. The technical scope of this project was validated with the following C-ITS services. So the C-Roads service we chose was signalized intersections, and more specifically, we chose the signal phase and timing information. We had the spot AM and map AM messages only presented previously, so the signal phase and timing and the intersection topology. And the type of the communication was infrastructure to vehicle. So here I have a technical picture of the pilot system. On the top hand side, we can see the long-range communication channel we had. So we had a traffic light controller at the intersection that was generating map and spot messages and sending them to central ITS station in Tampere through fixed public network. From the central ITS station, our Nordeon C-ITS service provider was subscribing to these messages and sending them through mobile networks to vehicle, where we had a mobile application that was capable of processing and receiving these messages. And below that, there is the short-range communication. So we had a roadside unit installed at the intersection near the traffic light controller. It was connected through local fixed network to traffic light controller, and the TLC pushed the same spot and map messages to the roadside unit. So the roadside unit received these messages. It added the signature, the PKI signature, and broadcasted them over short-range direct communication using 5.9 GHz channel. And in the test vehicle, we had an onboard unit that was capable of receiving these radio messages and displaying them to the end user. So the short range we had a Comsignia C-V2X roadside unit and onboard unit. And for the long range, we had IP-based communication through Telex and Nordeon Asgard C-ITS service provider. And the traffic light controller we had was Cartesio from La Semaforica, and it was generating SPAT-EM and MAP-EM messages. The interface to Telex from the traffic light controller was the SI interface, and to the roadside unit we had this Comsignia proprietary protocol. And both roadside unit and onboard unit were enrolled to the European C-ITS credential management system. So here I have a picture of one of the test cases we did. So you can see on the right-hand side the actual traffic light signal at the intersection that we tested on. And the left-hand side we have the two mobile applications mentioned. Left of those is the short-range Comsignia one, which is connected to the onboard unit directly, and it's receiving the short-range messages and displaying the content of these messages. And on the right-hand side, we have the long-range application made by Nordeon, and it's receiving the same messages from the long-range communication channel and showing the content of those. And on the top left corner, we have timestamp running that we use to calculate the differences between the actual traffic light signal on the intersection and the two mobile applications. So the final report will be ready on beginning of the next year, but we have some initial results here so far. So on the left, there's a diagram that is showing end-to-end latency through 10 cycles of status change from yellow to red. And the latency of these communication methods have been calculated with the previous slide test scenario. So the blue color is showing the long-range result, and red color the short-range result. So the delay between real traffic light status change and the status change in both mobile applications. And then the delay is rounded to closest tenth of a second. So as we can see, the numbers are quite even, and there's really not significant difference between these two communication methods. So for human eye, this is basically both of these are a blink of an eye. For the short-range communication specifically, we measured a latency of 40 milliseconds directly between the roadside unit and onboard unit. So the majority of end-to-end latency can be seen to be generated by the devices and applications themselves. The average size of the messages we measured was 526 bytes for SPAT and 994 bytes for MAP. And all of the messages that the onboard units received from the roadside unit were signed as probably and expected. So briefly about the certificates we used. The used certificate authority was Microsec, and they are registered to the European Certificate Trust List. So the cellular vehicle-to-all short-range devices were interoperable with the EU CCMS. And what we found was that some device manufacturers might have tools to automatically enroll devices. And this was also the case with Comsignia devices together with Microsec. The long-range solution, long-range communication chain didn't support signing messages when this project was started. Then some findings. So what we found was that there's no standard or even de facto standard in place for communication between the traffic light controller and the roadside unit. So we had to do some development work together with the traffic light controller manufacturer to implement the communication between these. The latency differences between short and long-range communication seem to be surprisingly small. And this is surprising because the long-range communication chain has much more backend and software components and also best effort networks. We found that measuring the latency between different hops in the entire communication chain from end to end proved to be quite challenging as there are many actors in this chain. So as mentioned, the mobile applications affect the latency, and we also found some unexpected delays in mobile app level during our longer tests. However, the public fixed and public mobile network provided stable and quite well working platform for long-range communication in this project. This project underlined that the public communication platform doesn't give any guarantees, so there's no SLA in place. The occasional increased demand or coverage problems or problems in the teleoperator core networks or even cyber threats. These may lead to significant problems in critical C-ITS applications. And this is something we see as creating the backbone for infrastructure to support the automated driving in the future. Then the summary. So overall, the cellular vehicle, all tests were successful. We were successfully able to use and test the EU CCMS together with the short-range communication scenario. There was no standard for communication between traffic light controller and roadside units. We found there are some proprietary protocols, but no overall standard. No significant difference between delays in long-range and short-range communication in this test. However, this does not give any guarantees for other tests where other vendors or components might be used. But both methods provided well-working platform for at least an informative C-ITS application, like the signal phasing timing information. However, we see that the evaluation of mobile networks capabilities to support critical C-ITS needs to be done in larger scope in the future. Okay, thank you. This was all I had.
Thank you, Nico, very much. Very interesting. So we don't have any questions, but I have one question.
Okay.
You say that you don't have any de facto standard about the roadside unit or the traffic light controller. Did you check the ITLC architecture? I think there was at least one solution for that.
You mean the Dutch ITLC?
Yeah.
Yeah, there is the RIS. I know the roadside.
Yeah.
But when we talk together with the roadside unit manufacturer and the traffic light controller manufacturer, there seemed not to be this kind of like, let's say, European level or global level standards how this should be done. They had some proprietary protocols for some different controllers, like there was some for Svarco controllers or some American controllers, but there was no clear standards that we found.
Okay, thank you. So I think we don't have any other questions, and we are good on time. So Ville, are you ready?
Yes, I think so. Good morning to all.
Good morning.
I'm gonna share my slides here, so just a second.
Could you put a volume up a little bit? So I think.
Ah, you don't hear me?
Yeah, I can hear you, but it's quite slow. Yeah.
Let me check if the mic should be on, but
Okay.
I don't know if you don't hear me.
We can leave it that.
Okay.
You hear enough good.
All right. Just to double check that you also see the slides.
Yes, we can see.
And you see it in the normal mode, not with
Yes.
okay, perfect. Good. Am I good to go then? Yes, so okay, good morning to all. My name is Ville Kilpi and I work for a company called Sitowise here in Finland. And I work as a specialist and project manager in smart mobility related topics, such as digitalization of transport sector and automated mobility. And today I'm here to tell you about our study, which is the utilization of commercial mobile networks in the implementation of C-ITS services. So as Nico mentioned on the last presentation, one of the findings that larger evaluation needs to be done for the data needs of C-ITS messages. So this study is actually exactly that one. And of course, Nico has been also part of this study, as has been Ilkka, the earlier presenter. So we have a good combo here today. So the agenda of this presentation goes as follows. So first, I'm going to clarify the aim of the study and the research questions that the study aims to answer. And then we will go through the key points of the study itself and the key takeaways, and we will finish with the thoughts for the future as the work still continues. So as with the first presentation, this one is not yet published either. And so if we begin with defining the scope, it goes as follows. The aim of the research is to study the performance needs of C-ITS services in mobile networks, as well as to define common service level framework criteria to cover various scenarios of use of services. And in order to answer the aim of the study, we formed some research questions. And the main question, of course, is how suited current commercial mobile networks are to serve C-ITS services. And if there are any bottlenecks, what are they? So in order to be able to answer these questions, we need first to estimate the data capacity needs of C-ITS services, as well as the capacity of the mobile network performance. And of course, we need to define what kind of methods should be utilized to measure C-ITS related needs on mobile networks. When we have conducted the analysis of the mobile network performance, we can get back to the possible bottlenecks and address the development needs. So we will address them in terms of technical, regulatory, and economical perspectives. And this is the part of the work that still is to be done. So all in all, the work is divided in 3 work packages, and today we will focus on the first 2 of them. So okay, this seems pretty straightforward, right? Well, because I'm an engineer, I like to present simple things in a more complex manner. So here's the process diagram full of boxes and arrows. But no worries, we will go through this diagram piece by piece. Unfortunately, because of the time restrictions, we will not have time to go through every detail, but we can provide a couple of hundreds of pages of reports for you to read. And of course, there should be time for some detailed questions after the presentation. But just to give you an overall picture of what is going on, the top part here presents the light blue color represents the C-ITS service related teams, and the bottom part, which is colored dark blue, represents the mobile network related teams, and the right hand side, which is the gold color, represents the analysis of current state. So let's get started from the beginning, which is of course, the C-ITS performance metrics and key performance indicators. What should we actually measure? We started the process by selecting representative C-ITS services for a closer inspection. And the selection criteria were, for example, legislation, country-specific needs, and message type. And we came up with the list of services very familiar already from the earlier presentations of yesterday and today. So the selected C-ITS services include, for example, roadworks warning service, signalized intersection service, and probe vehicle data service. Now when we had the list of services, we needed to figure out what are the suitable key performance categories and indicators to measure. And we came up with a list of relevant categories and indicators by combining suitable telecommunication system performance indicators with the C-ITS communication performance indicators and excluding the non-relevant metrics. So main categories are availability, with the measurable quantity being the network coverage, reliability, with the measurable quantity being the packet loss rate, and integrity, with the measurable quantities being latency and throughput. So now, after specifying what to measure, we needed to form a framework for the service level. And this was done based on the C-ITS quality of service requirements, which were analyzed using the 5 selected C-ITS services. And 4 service levels were defined with the specific threshold values from the literature, and the service levels were from level 0 with unreliable operability to level 3 high operability. And after the service level framework, we concentrated to the scenarios and establishing the framework for them. So this means that establishing the parameters to analyze, and in our case, these parameters were related to the environment, such as vehicle density, information density parameters, connectivity architecture models, and message model parameters. And at the end of the day, C-ITS messages are data messages that need to be transferred, and they are quite modest in size, to be honest. So in order to estimate the data traffic caused by the C-ITS messages, we needed to develop these scenarios a little bit further. And this was done as follows. So basically, the amount of data traffic caused by C-ITS messages depends on the number of actors sending and receiving the messages, as well as the information density. So how much data and how often the messages are being sent. And we varied the percentages of vehicles capable to C-ITS communication, as well as the traffic flow of vehicles in different situations. So that's how we got these 4+1 different scenarios. And we also varied the information density factors, such as the update rate. So how often the message is sent, for example. So as you can notice, the values for the data traffic here in this charts and pictures, they are quite reasonable, but however, the range of threshold values is quite wide. Keep this in mind. We will get back to this later on. All right, so moving on to the mobile network side of the diagram. Hopefully you are still following. Now when we know what we need to measure, we need to specify how to measure it. And the measurement method framework developed in this work doesn't actually suggest any new measurement techniques. Rather, it's a process how to utilize existing techniques most efficiently. And this means utilizing available information, such as coverage predictions from the operators, to identify potential problem areas where additional information might be required. And this additional information then can be collected from the measurements with the scanner or stress tests, for example. And by analyzing this data, the status and development of coverage and service level availability in commercial mobile networks can be validated then. This slide shows a real-life example how the coverage predictions provide a good general indication of the available service level, but field measurements are needed to verify actual road coverage accurately. So the purple colors here in the right-hand side of the picture, they show the coverage predictions for the basic and 30 megabytes per second coverage, but the field measurements from the northern part of Finland shows that at some points the coverage is worse and sometimes better than predicted. So these colored measurements here in the farthest right picture. And Finnish Transport and Communications Agency Traficom collects these coverage predictions from operators, but these field measurements, they are done only for a specific purposes, and as the measurement data what we have here, this was not specifically for this project, but the data was available from the earlier measurements for us to use. Okay, so now we will get to the point where we actually can answer the main research questions that I presented earlier. So how can we utilize the proposed measurement method framework to validate the C-ITS service level framework? And just to refresh your memory, on the upper left-hand side corner, the service levels are presented and applied for closer inspection with the real-life dataset, which is the lower left-hand corner. And this dataset includes almost 550 kilometers of driving measurements in the suburban area of one of the biggest cities in Finland. Again, these measurements were not done for this project, but the dataset was available for us to use. So when this combined, we can get to the right-hand side of the picture, and in the upper right corner, the picture shows that when assessing the overall service level availability, the values are more than 98% over the service level 2 values, which is more than enough in most cases to support the majority of C-ITS message required communication. So the upper side here in the picture. But however, when we drill down to individual areas of interest, as the lower picture represents, then we can actually identify some local issues in some part of the networks. But as a conclusion for this slide, the proposed measurement method framework allows validating the service level availability and support the flexibility in the analysis. And finally, we can get to the big question. So how well are the mobile networks of today able of serving the C-ITS traffic of the future? Well, quite well actually. The upper left corner shows again the capacity estimate for the C-ITS data traffic as shown earlier. So this is the same picture than a couple of slides ago. But this is now combined with the capacity estimates of the mobile networks in the lower left-hand corner. And this picture represents the typical capabilities of mobile networks in different environments in terms of available bandwidth and the distance to the base stations. So when combining these two things together, so the estimated load to the available capacity from the left-hand side, we can move to the right-hand side of the picture, and we will get the feasibility assessment of C-ITS messages. And as you can hopefully see, this table suggests that in various scenarios that we developed for this study, the percentage of C-ITS message-related data traffic the data traffic demands from the mobile networks capacity is actually quite modest. So hence we can conclude that the estimated capacity in Finnish mobile networks today is sufficient to carry the expected C-ITS traffic even with the 2030 volumes. However, in situations of extreme traffic congestion, service availability may become an issue, as some of these points point out, but I want to highlight that this is like the extreme traffic congestion. So okay, so I know that there was a lot of information, but hopefully there was something that stayed in your mind. And while we are discussing about the key takeaways, I would like to ask some questions from the audience as well in the form of poll. So if a moderator, Alva, if you could open the poll at this point for the audience to share their views about the expectations towards the C-ITS services. So while you answer the questions there, I want to share some of the key takeaways. So my main message to you is that the present state of mobile network is largely able to support the expected C-ITS data traffic. Of course, the inherent mobile network challenge with varying service level availability will persist, and solutions for managing data traffic levels need to be considered in the C-ITS deployment and development work. Another key point is that by utilizing the proposed measurement method framework, the service level availability can be analyzed elsewhere as well. So, for example, same thing could be done in Sweden or Norway. And lastly, there are still many uncertainties regarding the adoption rate and implementation of the C-ITS services, as also pointed out in the earlier presentations. And therefore, I'm really interested to see what were your answers to the questions in the poll. Well, as I mentioned, the work still continues, and the next step for the process is to address the recognized development needs. And even though the mobile networks are quite capable, as stated earlier, the 5th generation mobile network technology brings us quite interesting possibilities in terms of network slicing, for example. And in addition to the mobile networks, we will take a closer look on the C-ITS services themselves, as well as the measurement method in order to obtain more detailed measurement information. And for the recognized development needs, we will propose operation models taking into consideration the regulation, monitoring issues, and also the cooperation models. So I think at this point I will conclude my presentation, and thank you for your interest for this topic, and I'm also happy to answer some questions.
Thank you, Ville, very much. Do we have any questions here? At the moment, no. I have one question. You say there is some unreliability about the mobile networks. What kind of unreliability do you mean that we need to take into account if we are talking about the C-ITS services?
Yeah, I mean that there is always some level of unreliability in the sense that even in the urban environments where the connection is most of the time good, there can be some blind spots or places that the connection is not available or as good as predicted. But then again, these are quite small sections that the connection is not sufficient. In that sense, that was what I mentioned about that needs to be taken into consideration of the C-ITS services when developing these, that the connection can be available even though it's not 100% of the time full connection.
Yeah. And there might be some services which are need more reliability and some services what are not so.
Yeah, exactly.
Not only
that's something that we try to address with the service level framework. So at some services might be capable of operating with the lower service level, and then the higher service level that I mentioned, then that could be in the case of some kind of maybe remote operating or control or that kind of issues, like really need for a high end and high quality connection. But many of these C-ITS messages, they will be sufficient with the lower service level frameworks.
Yeah. Then there is one question that perhaps you could comment on the poll result.
Yeah, I don't see the results. So maybe if someone has the result.
If you take out your presentation mode or this not share your screen anymore, I think you find those in the conversations or comment box.
Let's see.
We have time here before.
Okay, yeah, now I see them. Yeah. Okay, so first questions about the if the C-ITS service will be available in vehicles in 2030. So most of the people, more than half of the audience believe that some new vehicles will have them. So not all of them, but some. But actually, there is also 1/3 of the people who think that all new vehicles have them. So maybe you can conclude from here that almost like the major part of the new vehicles would have the C-ITS service available in 2030. There is actually no one who believes that there are no C-ITS service available. So I think we have some kind of C-ITS believers here, which is not surprise, of course. Okay, but this is promising, yeah, for the future. And then if we check the second questions, how do we use the C-ITS services? So major part of the audience, 2/3 of the audience believe that it's integrated in the vehicle infotainment system, which is I believe this is the way that you could utilize the EU credential system. So as in the Nico's presentations, there the mobile app connection that was not with the credential system. But then again, these might be easier to implement, but because the ones which are integrated to the vehicle infotainment system, then it means that it takes consideration of the age of the vehicles as well. So in Finland, this might be a little bit I don't know, making things a little bit slower. But interesting to see the questions. Yeah, thank you for answering.
Thank you, Ville. And now we don't have any more questions. So, Johan, are you ready?
Yes, one moment.
Yeah.
Okay, sorry.
Now you need to switch
Yep.
the screen.
Yep. I just noticed some. Sorry for this. Okay. Yep. Okay, so I will speak about cybersecurity and Cellular C-ITS. Basically, the work which I will present has been done in 2 of the projects which already have been presented here. First, related to the roles of the government, and then I will follow up with how it was been done in the C-ITS pilot, on which also Nico has already been speaking, and then conclude with what are still the open issues in cybersecurity for Cellular C-ITS and some recommendations. So regarding the basis of the cybersecurity is the C-ITS trust model, which has already been mentioned in several of the presentations. If you look for the definition of C-ITS, then key in this definition is the use of the words secured and trusted messages. If the messages are not secured and trusted, it is considered as only ITS and not C-ITS. And the new ITS directive also refers directly to the EU CCMS, which is basically a distributed PKI system. So you have, like you see here, you have some common European elements, which are the trusted list manager and the central point of contact. And then you have each actor, C-ITS actor, basically can select its own root certificate authority. So, for instance, a member state can decide to either use to set up its own root certificate authority or to select the European root certificate authority. And so we have 3 security levels. Level 0 is for testing. This is currently operational. Level 1 is a transition phase. Some countries are already moving towards level 1, but not all the documentation is ready yet. And level 1 is a transition phase, which will end according to the documents which are currently under preparation at the end of 2025. So there's 2 years for this transition phase, and from that moment onwards, from 2026, we would be in the operational phase, which would mean that all devices which were brought on the market and all operators should be fully certified. So here's again another view of this C-ITS trust model with here the central elements. Then we have the root, the PKI operators, which is the root certificate authority, and two sub-CAs, the enrollment authorities and the authorization authority. The enrollment authority delivers the long-term certificate, which is basically programmed into the device, and the authorization authority gives a pseudonym which can change more frequently. So when a manufacturer wants to be included in this system, he has to first have an ISMS, so an information security management system, which has been, which is then certified by an accredited auditor. Also, the PKI has to be audited. If he brings a device into the market, this device has to be also certified according to a system called Common Criteria, and this is done in a SOGIS certification lab, which has got the approval from the National Cybersecurity Certification Authority. So for being able to operate, he then applies to the enrollment authority. In case the manufacturer also wants to provide services for governmental purpose, then the approval also has to come from a national authority. So in the certificate contains a field called the service-specific permissions, which basically tells which services the operator, the station is allowed to provide. And for some of these services, you have to ask the permission of the national authority. So national authority has to decide who can use which permissions, and then also what is exactly the procedure for getting these permissions. Once he has enrolled in the enrollment authority, he can ask for a certificate for the C-ITS station, and then this can operate and communicate with other C-ITS stations. And then for this, they also always exchange certificates. No connection basically to the PKI is directly needed. All the information should be stored locally, and from time to time, he also has to get connect to the CPOC in order to load the certificates of the root certificate authorities in order to check that the root certificate authorities are still valid. They still have the permission to send certificates. When dealing with cellular communications, basically the only ITS stations which are needed are a central ITS station. Roadside ITS stations and vehicle ITS stations are basically only relevant for short-range communication. And certain long-term communications, as you know, the main standard-based communications are between the operators, and the communication between the operator and the vehicle is basically up to the service provider. So, but the C-ITS model basically uses U is basically performing the security at message level. So you will have, if you have a message, like a DAN message, it is encapsulated with a security envelope. This security envelope also contains the GeoNet header. And then if you want to send it over the over the long range communication between backends, you have to add also other header, the EMQP header, which performs the which allows the routing between the interchanges, and then the TLS header. And the TLS currently uses the X509 certificates. So we have two different types of certificates, which means also that we have two different trust domains at this moment. Okay. So now going back to the roles, this is a similar slide as you had in, and Ilkka has this in his presentation. He already mentioned the centralized station provider, which is either the FinTraffic or the municipalities. And the EU, for the division providing the permission for dealing with the service-specific permissions, to assign them who may use them, and the processes for getting these specific permissions. This is to be assigned a role for most likely to the Finnish to Traficom. And then for the root certificate authority and the sub certificate authorities, this would be the subject of an economic operator, which is assigned, which has a contract with Traficom. Okay, if we now go to the cybersecurity example, briefly, Nico has already addressed this in his presentation. So as Nico said, we have used the microsig L0 at this moment. Because there is a collaboration between ComSig and MikroTik, and there are specific APIs which make the use of this certificate very easy. Basically, you only have to do is which are the permissions which you want to add, and you just say that I want to send for instance, priority request messages, and then this can be automatic. This permission is automatically given. We also went through the process for getting the root certificate authority to get the certificate from the EU RCA. This is bit more complex, but still rather simple procedure. First, you have to register the organization, telling in which is the devices which you want to use, and then you have to provide a legal proof of registration of the organization and sign in an agreement. Then you can enroll the stations, and for this you have to just provide a table telling in here which are the permissions which you want to set in the device, and provide the public key, and then you get the private key in mail back. But when you want to go to L1 and L2, what the company then has to do is it has to set up the ISMS and have to start for applying for the ISO 2701 certificate. In level 1, so you have to, for this, perform a risk assessment, identify potential risks which you related to C-ITS, define how you will protect the assets, what are the action plans in case there is a breach, and who name the responsible persons in your organization. But for level 1, an internal assessment is only needed, and you have to confirm this by providing a self-issued statement of compliance. For level 2, you have to go to an external audit. So, and the process for getting the ISO 2701 approval can be rather long, up to 1 year or more. Then, if you want to bring devices on the market, then they have to be designed, developed, and assessed according so that they meet the C-Road specifications and also are compliant to the EU C-ITS model. So especially if you want to bring a centralized, if you want to have a central ITS station, because they're mainly once made, they are single products, they're not products which you buy normally from the shelf. For level 1, you have to go to an evaluation that the devices are protected against basic attacks. So this also would require that you have that SOGIS recognized test lab makes these tests. And in level 2, you have to go to a full certification required according to common criteria. This normally requires that you have, in case there is a protection profile available, then you have to use that. A protection profile is a document which contains all the requirements for this device related to information security and also the mitigation actions which should be deployed. But the writing a protection profile is also very time-consuming process. At this moment in C-Roads, they're already working more than a year on getting the protection profile for a roadside unit. Okay, so some of the open issues. First of all, there is the governance of the IP-based sessions layer security and how to govern the TLS. In the presentations from yesterday, was mentioned that at this moment, for instance, for the network of interchanges, this is handled by a single person, but how this would be handled at European level, this still has to be decided, and there have been discussions started at C-Roads to take this action forward. Then there is also the issue regarding the special permissions. So which are the services, which are the messages which a station can send. So this is basically also up to the process has to be set up nationally. So decided which actors can send which messages and how to get permission for this. And so the certificate policy currently mentions the term governmental purposes. And this, what exactly governmental purposes means, this is still unclear, and it can mean in one country it can include traffic lights, another country does not include it. So this also has to be harmonized at European level, and the process has to be started still. Then each country basically, or each actor has to decide, will you use national route certificate authority or will it use the EU RCA? So if you use your own route certificate authority, you have more possibilities to influence on who, on the grounding of the permissions to send this message, which is a previous point. But at current but the EU RCA is much more simpler, because then the EU takes care of it. You don't have to set up your own processes. But at this moment, it is still unclear. I did not find any information on how the service-specific permissions would be requested from the EU RCA in level 1 or 2. And setting up a route certificate authority is make it all possible that it make it more resilient to disturbances and exceptional situations. Then there's also still the issue of message signing. So we have at this moment, we have two trust domains, one for the message signing and the other one for the central ITS stations and including the interchanges. But so there are solutions standardized. There's standard available who mentions the use of TLS with IEEE 1609.2 certificate. So which would mean that if you also do the communications over the back end would use the same certificates as the ones which are with the messages. But there are standards and commercial products still missing. Also, one other issue of discussion is the GeoNet header really needed? The GeoNet header is a requirement from some countries within C-Roads because it allows, but the only function it would allow is that when you have a device supporting both short range and long range, that it can forward a message which it receives over long range, over short range to the neighboring vehicles. Then another open issue is what already has been mentioned previously, is the amount of central ITS stations. Is that should each actor involved in this ecosystem have its own central ITS station? This would require then in full deployment that they would need this ISO 2701 certification. And this may seem very challenging for small municipalities or for roadwork contractors. So there should be then the possibility for central ITS station to sign on behalf of other partners. And this has basically been done in the NordicWay 3 project, where in Norway, NPRA has signed on behalf of the roadwork vehicles, and in Sweden, you have the solution that at the interchange, the messages coming from the roadworks contractor are signed. And there's basically no, in the certificate policy, there is no, this does not prevent doing this, but as the central C-ITS operator, he takes full liability of the message. There should be definitely specific trust relation between the different partners. And then the last issue, which is here, is related to the certification of central ITS stations. So there's currently no protection profile available. There is a discussion, is this really needed? Because all central ITS stations are most likely one of a kind, and this would mean that we could have a more simple security target evaluation. Additionally, in Finland, there is the issue that there is currently no existing SOGIS conformity assessment body, so it either has to be set up or the devices have to be certified in a laboratory abroad. Okay, so this is all for my presentations. The results will be reported in 2 reports which are still oncoming. And if you have more questions, I'm very eager to answer them.
Thank you, Johan, very much. We have at least one question here. I can read it here. What do you think is the biggest challenge in reaching L1 and L2 technical and organizational? Do you see any benefits or challenges with the distribution of responsibilities between different authorities as in the Finnish study?
Okay, the Finnish study has basically been targeting what needs to be done at level 2. So the major challenge I see in getting the certificates in the different actors to have this certification to change their internal processes so that they are compliant with the level 2 system. This I think is the biggest challenge.
Okay. I have one question regarding. Okay, there is another one. Can you see it?
Yeah. So the question.
Yeah.
Okay, so have any stations been tested by SOGIS lab against common criteria profile, and were these fixed or mobile stations? So at this moment in C-Roads, they are developing the production profile for roadside units. So at that moment, there is still no being done, but there is a protection profile available for trailers. So if there has been have been stations tested, it has most likely been in either Germany or Austria, and then most likely the lab which has tested it is TUVIT. But definitely regarding the mobile stations for vehicles, I know that there is a protection profile available, but I have not aware if any of the devices for instance from the ones which are now in the Volkswagen cars have been tested against these criteria.
Okay, I have one question, quite practical, related to the traffic lights. So you have in the slide 8, you have the one picture that if according to EU CCMS L2 operational phase, and if we have a closed fixed network inside the traffic lights, do we still need to sign every messages? What we are sending, for example, as button messages.
Okay, so this one, yeah, basically, so if you send over short range, then
if you have a this kind of that kind of Tampere node, for example, that Telex kind of system, and we have a closed fixed network, and we want to, or according to L2. So do we need to sign every button messages? That kind of.
According to C-Roads, Yes. So if you mean over the long range, basically, then this can be done either, and this can be signed either the traffic light controller or at the node. It depends on perhaps dependent on if the traffic light controller has the inbuilt system, or but most likely it will be the node. It will be here in the node, because the signing also requires the protection profile, so it has to be in the ITS station who sends it. But in case you would have a device which has an RSU, then it can also be sent at this RSU if it's if the message of the RSU would be the one which is sent to the temper to the node.
Okay, thank you. Now it's time to the closing words. So Pekka, are you online?
Yeah, thank you. It is always a pleasure to be on the sweet spot between real experts presentations and the coffee break. But I'm Pekka Pussinen from Finnish Transport and Communications Agency Traficom, and I'm coming from the Digital Connection Service area from the Department of Frequencies. So my perspective is on the communication side. I was planning to tell you and remind you about the wireless communication needs on the C-ITS services, which really will need, and the idea that the technological neutrality principle what Finland has been using in previous years in other communication needs to results efficient and cost-effective networks. And I was planning also to tell you about the commercial mobile networks and their revolutionization on different communication needs, starting from mobile phones, which resulted the ramping down of the fixed copper networks, short message services, SMSs, which then ramped down the pager networks in Nordics, and the mobile data when it was available, the IoT solutions of the infrastructure, especially roads and electricity networks, started to use these commercial mobile networks more and more. And after 4G and 5G data available, the conversion of operational critical networks like the public safety network, for example, in Finland, is going to the commercial mobile network instead of Tetra-based private network instead. After this history and after this previous experience, it is nice to see what would be the future of the C-ITS communication services. About the technology also on the vehicles on the roads. Virtually all new cars has some kind of mobile technology on board because of e-call and most probably also for the other uses, diagnostics use and the other purposes for the car and for the vehicle. In future, we have the poll there. We will have practically all the vehicles on the roads will have the mobile phone technology on board. And because of this and because of the economy scale of the public mobile networks, all relevant features will be implemented to all relevant devices. And therefore, if C-ITS services are available on the mobile technology, even short range or long range, they will be implemented there, and it is usually more cost effective than the private services. Ilkka, Olli, Niko, Ville, and Johan already told you plenty of what we have been doing on these projects. The cybersecurity and data sources trust is a mandatory part for the C-ITS services, and they need to be tackled better earlier than later, because the trust information is the requirement because for the services, because it will be used for the decision making. Either the human is doing the decision or automation is doing the decision, but all the information needs to be trusted. We had a good understanding of the preliminary understanding of the roles needed for the C-ITS deployments, and the Transport and Communications Agency, Traficom, and Traffic Infrastructure Agency seems to be has the quite important role for setting up framework. For the short range, the mobile technology on the pilot project was demonstrated, so it is available and usable in the manners with the commercial off-the-shelf technology. And also it showed some promising results about converging short range and long range communications also in CV2X. And finally, the mobile communication network seems to be quite feasible for the use for the C-ITS services up to next 7 years. And the evolution of the communication infrastructure will even enhance the reliability for the use. And after all these, what we already have done, we don't need we need to understand that after 4G, after 5G, there will be a future evolution on 6G, which always gives more interesting perspectives for C-ITS and road users. For example, on integrated AI and sensing technology in road environments. From my behalf, thanks for all the presenters and the project teams behind the presentation, and of course the audience. And I hope that these were interesting for all of you, and you get some useful thinking for the further development and rollout of the services. Thank you.
Thank you for my point of view as well, all the presenters and all the webinar guests. Thank you very much. Now, short break before the next sessions.